Hello everyone. So today what we are going to discuss about is nothing but today we are going to discuss about the functioning of the heart, that is the cardiac cycle. Okay, so in this class we are going to discuss about the cardiac cycle. So what is meant by cardiac cycle? Cardiac cycle is the sequence of events occurs in the heart during one heartbeat or one complete heartbeat. What is meant by cardiac cycle? Cardiac cycle is nothing but here the sequence of events or series of events which are taking place in the heart in one heartbeat. Okay, so what are these sequence? These are nothing but the systole and diastole. What is mean by systole? Contraction. Okay, so you have to remember that systole is nothing but the contraction, whereas diastole is nothing but relaxation. Okay, so contraction and relaxation of both, that is atria and ventricles. Atria and ventricles. Okay, so here they are taking place in a series or in a sequence in one heartbeat. Okay, so you have to remember another thing here. One heartbeat equals to one cardiac cycle. Okay, so whatever the heartbeat you can listen, that is indicating the one complete cardiac cycle. So one heartbeat equals to one cardiac cycle. So can you tell me how many heartbeats are there per minute? Our heart beats about 72 times per minutes. Okay, so our heartbeat is 72 times per minute. So as you can see, one heartbeat equals to the one cardiac cycle. So we have to find out the what is the duration of each cardiac cycle. So 1 minute is nothing but 60 seconds. Okay, so 60 seconds divided by 72. Why we are taking 60 seconds? Because in 1 minute, that is the 60 seconds, our heart is beating 72 times. So that's why we have to find out the what is that cardiac cycle. Each heartbeat is nothing but one cardiac cycle. So 60 seconds divided by 72 cardiac cycle in 1 minute, which gives about 0.8 second. So the duration of single cardiac cycle is 0.8 second. Understood this? Okay, so the duration of single cardiac cycle is the 0.8 second. Now you can see this cardiac cycle is divided into the different events. First one is the joint diastole. Next, atrial systole. Third one is the ventricular systole. Okay, so you can start from any sequence because it is easy to understand if we are starting from the joint diastole. So that's why I am starting from the joint diastole. So out of 8 second, this complete cardiac cycle is taking the 8 second, 0.8 second. So out of 0.8 second, joint diastole will takes about 4.4 seconds, atrial systole 0.1 second, and ventricular systole 0.3 second. Okay, so these events are taking this much of time in whole cardiac cycle. So now you can see here in the schematic representation here. Here we are dividing. This is the joint diastole or complete cardiac diastole, it is also known as. So it is ranging about 0.4 second. Atrial systole 0.1 second, whereas ventricular systole 0.3 second. Okay, so this circle is indicating the whole 0.8 second, that is the cardiac cycle duration. So in that we have divided the based on the what is that timing, which event is taking how much of time. So first we will see about the what is that joint diastole. Joint diastole. As you know that what is meant by diastole? Diastole is nothing but the relaxation of heart. So what is the time for joint diastole? 0.4 second. So what is happening in the joint diastole? So you can see here SAN is not generating any impulse for contraction. Okay, so here in what is that conduction of heart, I have explained how the what is that SAN is generating, how the what is that impulse will travel throughout the musculature of the heart. Okay, so in this condition in joint diastole, SAN is not generating any signals for the what is that heart contraction. So that's why heart is not contracting, all chambers of the heart is in relaxed state. Okay, so diastole is nothing but relaxed. Joint means all chambers, so that's why it is known as the complete cardiac diastole or joint diastole. So what is happening in this? All chambers of the heart is in relaxed state. Relaxed state. Okay, so all the four chambers of the heart is in relaxed state. Apart from that, here AV and AV walls are open. Okay, so where the AV walls are present, you have seen in the structure of the heart between the atria and the ventricle, AV walls are present. So these AV walls are open in this joint diastole, whereas semilunar walls are closed. Semilunar walls are closed. So you can see if the AV walls are open, whatever the blood coming in the atria from the greater veins is directly entering inside the what is that ventricles. So as AV walls are open, the blood coming from greater veins into atria directly enters into the ventricles. By these 70% filling of ventricles is completed in the joint diastole. So you can see here, I will show the diagrammatic representation. So for example, this is the heart. All structure you have seen. For just understanding, I am drawing rough diagram. Okay, so now you can see here the pulmonary vein is there, which is carrying oxygenated blood. Here vena cava is there, carrying deoxygenated blood. Okay, so whatever the blood coming from the pulmonary veins in left atrium and right atrium and So whatever the blood coming from the pulmonary veins is entering inside the atria. As AV walls are open from the atria, these blood is directly entering inside the ventricles. So here also whatever the blood coming from the vena cava, as the AV walls are open, whatever the blood coming from these into the right atrium is directly entering inside the ventricles. So like this, 70% filling of ventricle is completed in this step. Understood? Okay, so here SAN is not generating any impulse, all chambers are in a relaxed state and AV walls are open. So that's why whatever the blood coming into the left atrium by the help of pulmonary veins, that is oxygenated blood, is directly entering into the what is that left ventricle. Here also whatever the deoxygenated blood coming from the what is that vena cava into the right atrium is entering into the ventricle as AV walls are open. So by these 70% filling of ventricle is completed in the this step, that is the in the joint diastole. Okay, understood? Joint diastole. Next part is the next step is the what is that atrial systole. Okay, atrial systole lasts for 0.1 second. Okay, so atrial systole lasts for the 0.1 second. So now you can see that here in this direction we have to go. Okay, in this direction we have to go. First joint diastole we have seen. Next step is the atrial systole. Okay, so what is happening in atrial systole? Okay, impulse for contraction generated by the SAN is reaching to the atrium. Okay, so now the SAN is generating the impulse for the contraction. So you have seen that whenever the SAN is generating impulse for the contraction, first these impulse reach to the what is that AV node along with it both the atria. So that's why these atria will undergo systole or contraction. Contraction of atria is taking place in the what is that atrial systole as SAN is generating the impulse. Okay, so due to the contraction here also AV walls are open and semilunar walls are closed. Okay, so that's why due to the contraction of the atria is taking place, due to which more amount of blood is entering into the ventricles. So that's why remaining 30% filling of ventricles is completed. Okay, so 30% is completed in the atrial systole. Now you can see here in joint diastole ventricles get filled with about 70%. Now the remaining what is that 30% is filled due to the contraction of the atria. Okay, so this atrial systole, this is about the atrial systole. Okay, any doubt is there? I think you are not having any doubt. Okay, if you are there you can ask. Okay, so next one is the third step or third what is that part, that is the ventricular systole. Okay, ventricular systole lasts for 0.3 seconds. Okay, so now the impulse generated by the SAN impulse for contraction reaches to ventricles. Okay, so first impulse for the contraction is reaching to the atria and AV node. From the AV node it is going to the bundle of His. From bundle of His along with the right and left bundle of His and the Purkinje fibers, these impulse are reaching to the ventricles. So now the ventricles begins to contract. Okay, so ventricle begins to contract. Okay, so now you can see as soon as ventricles started the contraction, the pressure inside the ventricle is greater than that of the pressure in the what is that aorta and pulmonary artery. Okay, so when the ventricular contraction started, at that time due to the pressure AV valves will closed. Okay, so due to the at the beginning of ventricular contraction, AV valves will close, and these closing of AV valves will produce first heart sound, that is lub. Okay, so lub sound is producing at the beginning of ventricular contraction. Okay, so pressure in ventricles increases as compared to pulmonary vein, pulmonary artery and aorta. Okay, so whenever the ventricular what is that contraction started, due to the pressure the AV valves will closed. These AV valve will produce the first heart sound, that is the what is that lub. Okay, so it is the first heart sound. Next you can see here in the diagrammatic representation, I will show you how it is exactly taking place. Okay, so what I am drawing is the what is that diagram of the heart. Okay, so for your understanding I am drawing roughly the complete diagram we have already completed. So now you can see here these are the AV valves. Here you can see what it is there. Here aorta is there in left ventricle. Here pulmonary artery is there. Okay, so these aorta and pulmonary artery is guided with the help of what is that semilunar valves. Okay, semilunar valves. So now you can see as soon as the ventricle begins to contract, the pressure inside the ventricles is increases. Pressure inside the ventricles get increases. Due to this pressure you can see these AV valves get closed, and closing of wall is producing the first heart sound, that is the lung. Okay, now you can see here these AV walls get closed. AV wall get closed. Now the pressure is on the semilunar walls. So as soon as the ventricles are contracting, now the AV walls are closed. So these AV walls, what they will do, they will prevent the backflow of blood into the atria. So now the pressure is on the semilunar walls of pulmonary artery and the aorta. Due to this pressure, the semilunar walls will open. Okay, so now semilunar walls will open due to the contraction of the ventricles, and blood is ejected out of the heart. Okay, so blood is ejecting out of the heart by the help of pulmonary artery and aorta. Okay, so pulmonary artery and aorta is, what is that? With the help of these two, the blood is going out of the heart. So it is known as the ejection of blood. Okay, so blood is ejected out of the heart with the help of pulmonary artery and the, what is that, aorta. So now you can see here with these aorta, these semilunar walls present in the aorta will open. Okay, so in pulmonary artery also it is open. So blood is entering inside the, what is that, these aorta and pulmonary artery, and with the help of this aorta it is going to all parts of the body, and through the pulmonary, what is that, artery, it is going to the lungs for the oxygenation. Okay, so this is the, what is that, contraction of the ventricles. Now as soon as the ventricles get contract, after that, for the duration of how much, for the duration of 3 seconds they will undergo contraction. Now the next part is the relaxation of ventricles. Now if they are completed the ventricular systole, that is contraction, now they has to relax. So as soon as, whenever the ventricles are undergoing, what is that, relaxation, at that time the blood whatever is there in the aorta is coming back to the, what is that, ventricles. Okay, whatever the blood present in the pulmonary artery is coming back to the ventricles. So at the beginning of, we'll erase this. At the beginning of ventricular diastole, semilunar walls get closed to prevent backflow of blood into ventricles from aorta and pulmonary artery. Okay, so to prevent the backflow of, you can see here, as soon as the, what is that, semilunar wall will close, it will prevent the backflow of blood into the ventricle from the aorta and pulmonary artery. Okay, so these closing of semilunar walls, when it is taking place, closing of semilunar walls, beginning of ventricular diastole, these will produce the second heart sound, that is dump. Okay, so opening of wall is not having what is that any sound, whereas closing of heart is having the sound. Okay, so the first heart sound is produced during the what is that beginning of what is that ventricular systole, and second heart sound and due to the closing of AV walls, whereas second heart sound is produced at the beginning of ventricular diastole due to the closing of semilunar walls to prevent the backflow of blood into the ventricles from aorta or the pulmonary artery. Okay, so now after that these ventricular systole is nothing but the next step is started, that is the joint diastole. So now you can see here this whole cycle will be repeated again. Okay, again the in what is that ventricular systole, as the what is that SAN is generating impulse for the contraction reaches to the ventricle. After that, for a period of 0.4 second, the SAN is not generating any impulse for the contraction. So that's why all chambers of the heart is in relaxed state. So that's why next step is the joint diastole. That is the joint diastole is nothing but it includes the what is that ventricular diastole also. Okay, so by these the whole process will be repeated. Okay, so whole process will be repeated and this repetition is taking place. Now you can see another thing here, how much blood is pumped by the ventricles in each cardiac cycle. So first one is the first you have to understand that what is stroke volume. Stroke volume is the amount of blood pumped by each ventricle during single cardiac cycle. Okay, so whatever the blood pumped by the each ventricle in single cardiac cycle is known as the stroke volume. Okay, so what is the stroke volume? How much ml it is? It is 70 ml. Stroke volume is the what is that 70 ml. So stroke volume is 70 ml in. Okay, so what is stroke volume? Blood pumped by each ventricle in single cardiac cycle. Next one is the another thing, don't confuse between what is that cardiac output and stroke volume. Next one is the cardiac output. Okay, same amount of blood pumped by each ventricle in 1 minute. Okay, so whatever the blood pumped by the each ventricle in 1 minute is known as the what is that cardiac output. Okay, so you can see here one cardiac cycle, whatever blood pumped by the each ventricle, stroke volume, and the amount of blood pumped by the ventricle in 1 minute is the what is that cardiac output. So here can you find out the cardiac output? Cardiac output equals to heart rate or heartbeat into the what is that stroke volume. So how much heartbeat is there or heart rate is there? 72 times per minute. And how much blood stroke volume is there? How much blood pumped by the each ventricle in single cardiac cycle? So in 1 minute 72 cardiac cycles are there. So that is 70. So total 5040 ml or approximately 5 liters of the blood. Okay, so cardiac output is the what is that blood pumped by the what is that each ventricle in 1 minute, that is approximate 5 liters per minute. So our heart is pumping blood, our each ventricle is pumping blood about 5 liters per minute. Okay, so you have to remember this. You have to make the difference between the what is that stroke volume and the cardiac output. Okay, so based on this questions will come based on the what is that cardiac output. And you can see here this is what we are talking about is at normal physiological conditions. At normal physiological conditions, our heart is pumping, our ventricles is pumping about 5 liters of the blood. But if you are doing exercise, if you are doing normal exercise, if you are doing what is that strenuous exercise, very what is that successful exercise you are doing, at that time these cardiac output can reach up to 15 liters per minute or the 20 liters per minute. Okay, so per liter. Okay, so like this, because the heart rate is increasing at that time. So in normal physiological conditions 5 liters of the what is that blood is pumped by each ventricle. So this is about the what is that cardiac cycle. If any doubt is there, you can ask me. Apart from that, you can see here, can you answer these questions? Okay, so what is the duration of atrial diastole? Okay, what is the duration of atrial diastole? Can you tell me? You can see here. You can see here atrial systole lasts for 0.1 second only. So remaining time the atrial diastole is there, that is 0.7 second atrial diastole. What about the ventricular diastole? Ventricular diastole is here you can see out of 0.8 second, 3 second is of ventricular systole. So what is the duration of ventricular diastole? 0.5 second. 0.5 second is the ventricular diastole. And you can see at this point what is that lub sound is produced. At this point lub sound is produced at the beginning of ventricular systole. Okay, you can see here this is the beginning of ventricular systole. So here first hard sound, that is lub, is produced, whereas here at the beginning of joint diastole includes ventricular diastole also. So at the beginning of ventricular diastole the dub sound is produced. So can you tell me what is the time duration between lub and dub? What is the time duration between the lub and dub? It is about what is that 0.3 second. It is beginning, it is the what is that ending. So that's why what is the time between these two? That is 0.3 seconds. Okay, so the difference between the lub and dub sound, what is the time duration? 0.3 second. So can you tell me what is the difference between dub sound and lub sound? First lub sound and dub sound, that is 0.3 second. I am asking reverse. First dub sound and the lub sound. So dub sound and lub sound is having what is that 5 seconds. What is that duration? So you can see here dub sound is there. After that joint diastole 0.4 seconds. After that one is the atrial systole. 0.1 second is the atrial systole. After that lub sound will come. So that's why it is 0.5 5 seconds. Okay, so this is about the what is that cardiac cycle. Okay, hope you understood this one. Okay, so if you want like this what is that explanation, you can subscribe my YouTube channel. I will post the videos like this, so you will get clear cut idea. Okay, thank you. I will see you in the next class. Thank you and have a nice day. Bye.